My name is Dr. Kyle Bradley, and I'm a scientist studying geohazards at the Earth Observatory of Singapore at NTU. Recently, we learned about a very fascinating case of a geohazard, which is a potential tsunami caused by a landslide that could happen along the coast of Alaska. Working in Singapore, we are very familiar with tsunami. They're a very common hazard that affects people in Southeast Asia, and they're generally caused by earthquakes. In this case, in Alaska, glacial retreat caused by climate change has destabilized the slopes of the glacial valley along the coast. All the rocks and soil that were previously held up by glacial ice are now perched over the open ocean, and any small thing could trigger a landslide of that material into the water. If that happens, a huge tsunami wave could be generated that would impact the shores around the landslide, but also propagate into the bays of the surrounding area, affecting people more broadly. We know that this can happen because it has happened. In 1958, a similar event, which was triggered by a large earthquake, caused a landslide into a bay, and the tsunami that was generated by that washed the surrounding slopes of the valleys up to 500 meters above sea level. Coastal glaciers like this are fascinating geological features because they're one of the best examples of environmental equilibriums and feedbacks between systems. One of these coastal glaciers will grow or shrink depending on how much of the snow in its source region is preserved over the course of the year. And that's mostly controlled by the number of warm days in the year. As the glacier adjusts to this equilibrium, the surrounding landscape also has to adjust. And one way it adjusts is by changing where sediments that are eroded off of the mountains are stored or where they're eroded from. So generally, these glaciers live in this changing balance. But when the balance is disturbed rapidly, which is the case today because of anthropogenic climate change and warming, when the glacier retreats so quickly, it leaves behind a landscape which is much more disturbed than it usually would be. And specifically, it leaves behind all the rocks and sediment that were previously held up by the ice, but want to fall down or slide down into what is now the ocean. Here in Southeast Asia, we don't have coastal glaciers, but the lessons we can learn from this case in Alaska do apply in the broader sense. We do see rapid changes in environments, partially due to human activities like deforestation or changes in how we use the land, and also global climate change and rising sea level. These rapid changes have certainly created new instabilities and certainly created new hazards. One example of how we do this kind of work in Southeast Asia comes from the 2018 Palu landslides, which were triggered by a large earthquake. In that area, human change came in the form of irrigation of areas that were previously dry. That irrigation to support rice agriculture raised the water table in an area very close to a large fault. When an earthquake struck on that fault, that raised water table allowed liquefaction to occur over a big region that previously would never have experienced that hazard. That liquefaction then allowed landslides to form on gentle slopes, which swept down the valley floor and ultimately caused thousands of casualties. As compared to Alaska, where there might be a more remote hazard or population density might be small, in Southeast Asia, sometimes we see that people are living in densely populated environments very close to geohazards. So it's really critical that we understand how landscape changes or how environmental changes are predisposing these areas to similar destructive events. Here at the Earth Observatory of Singapore, we need to continue using basic science research and Earth observation with a focus on community engagement to better understand geohazards that affect people and to build a more resilient future for everybody.